I'll just give a brief overview introduction. But before I go there, see at 4 o'clock we have a session here or a help session here. For those of you who have not finished the React CRUD, that is mandatory. We are suspending all further classes in pre-FS till at least a big majority finishes that. Because there is no point. If you can't do a basic full stack application after 2-3 classes, you should be able to do create, retrieve, update and delete. That is a minimum skill. And I don't want to go on if you can't even do that. It's a waste of time. So we are just suspended the whole program till a majority finishes. I can't expect everyone. Today and tomorrow, both days, we are going to have sessions from 4 to 6, wherever. For those of you who are struggling, and many of you seem to be struggling with a basic application, is in this session is what is called as an agentic workflow. This is the point where LLMs start becoming very alarming, very dangerous, because as you will see today, they start thinking and they start acting. And if you understand this presentation and also the code associated with it, which is very easy, you will understand why I am scared and why you should also be scared that where things are going. Agentic workflow is the cutting edge of LLM. Hopefully, if I finish in time, you will be able to do an exercise. And I think you should design a flow of your own, because that will give you confidence that I can design a flow. Okay, so what is an agentic workflow? The concept is very simple. See, if you realize, LLMs are able to figure out language. We all know that. Now the next point is, can LLMs understand things? Well, once you can figure out language, the next thing is obviously you can understand. A thought after that is, okay, you have understanding, can you also choose your action and act properly? So surprisingly, they are also able to act properly. Now, what we are demonstrating here is a business process in which the LLMs do a lot of thinking, a lot of action. You provide the action, but which action to invoke, how to invoke, the agent decides. And if you really take this technology forward, it can be applied to very many problems. If you combine it with IoT, you have agents which can sense things and which can act on things. If you take any application domain, they will understand what's going on and then create a solution for what is going on. Now, people have taken this to entire code generation, where they have said, I'll just define the project. For example, you will say, I want an application, for example, let's say a CRUD application, which interacts with this kind of data and which gives me this kind of user interface. Well, we don't have to do anything much. We just have to set up the tools, as you will see today, and it will generate the application. So it means that you're useless. It will make you feel useless. And then comes the point where how do you stay relevant in this kind of a world? So we'll do this. Hopefully you'll do an exercise. There's a lot more to do in transformers, a lot more to explore. But honestly, it's a function of your ability. So we are going to talk about agentic workflows, and we'll talk about how they work, what are they, and how are they useful. I'm just using this to talk about it. So now agentic workflow is not coming from either OpenAI or from Anthropic or from Llama. It is coming from LangChain. So what they have done is, internally they obviously use the intelligence of OpenAI or Anthropic, but they value add onto that intelligence and create the agent. As of now, agents mostly come from LangChain, but then there are many other frameworks which are working on similar thing. An extension of this idea is multi-agent orchestration. We are not talking about that yet. We are talking only of single agent orchestration, one agent who is doing a lot of things. But the real power will come when I have a bunch of agents and I orchestrate among those agents, and it's capable to do that. I mean, the LangChain is capable of doing it. Only thing is, we are not having an example today. We'll have it. Generally, I have it as a later example, but you need to absorb this first, show that you are able to do this, and then we'll move on. So the agentic workflow basically combines LLMs, but they have an interesting idea which is not there in an LLM. They can reason, think, and act. It's also called React, not that React. This is a different React. So this ability to reason and act, which makes them react, is a power which LangChain brings or the agentic workflow brings. This is not there in LLM. LLM can only answer questions. It cannot reason, it cannot think, and it cannot act, obviously. Whereas these things, LangChain models or LangChain agents do that. So basically it combines language model reasoning with external tools. Each line is important. It uses external tools. Now, it is a question of your expertise. What external tools can you put in front of the LLM or the agent and say, here are the tools, now you use these tools. It is our ability to create those tools with external tools to enable dynamic, multi-step problem solving. And the kind of problems it can solve are pretty complex. We'll demonstrate the tip of the iceberg today. But those of you who will understand what I'm saying will understand that we can go far beyond. Okay, next. So at the core, there are these 3 or 4 people who are part of the agent architecture. So at the core, there is a decision maker. This ability to take decisions, which uses an LLM. So it uses the LLM to understand what the user is asking, but it also has a core of intelligence which takes a decision. That is called the main agent. And then it is supported by a bunch of tools. Tools can be either Python functions or they can be anything in the world which can be harnessed. It's just a question of having language binding. You ask them to do drug discovery, they will do drug discovery. You ask them to fire a gun, they will fire a gun. You ask them to do something else, they will do that. So they are external to the agent, and they are the tools which actually bring in capability. And then the agent works with something called an executor, who is the orchestrator who makes these tools work together. So these tools are basically working together in tandem to realize an objective. And the job of the executor is to knit these tools together so that they act in tandem. And toolkits obviously are groupings of tools. So you could have, based on your application, tools which do drug discovery, tools which monitor temperature, tools which do maybe an ERP system, tools which do a reservation. Anything which can be called through an API can potentially become a tool. So today almost everything in the world is API invocable. What can't be API invocable? You want to fire a gun? You have an API for that. You want to jump in a lake? You have an API for that. So which will do whatever is needed to take you, bundle you up, and take you and drown you, isn't it? API is available. So there are APIs for all kinds. In fact, I don't know how many of you read. There is a book by Dan Brown. The reason I'm mentioning it is, this book was written about 10 years ago, before the advent of agents and all this. The book's name, that was the last book so far written by Dan Brown. You know, Dan Brown is known for what? Which book of his is world famous? Yeah? Anyway. Okay, forget it. Don't even go there. Okay. Now, he writes in a book called Inferno. No, Inferno is not the book which is most popular. Okay. In which he visualizes an agent which actually the scientist creates this agent for his support, and one day the agent becomes so smart that the agent hires assassins, kills the scientist, and starts ruling in his stead. Now, this is all imagination. 10 years ago when I read this book, I also wondered whether one day such a thing would happen. But today if I sit in 2024 and read that book, I think it's all done. It is very easy to do that, whatever was visualized there. So anyway, next. So there are, as I said, there is agent, tools, toolkits. I think we already went through that. Okay. Now I think this is becoming a little monotonic. I'll give you a more pictorial invocation. So I'll try to describe it more graphically here. So see, here is typically how the agentic workflow happens. There is often in any organization a document. It starts with this. What does this document have? It has a policy. Some kind of a policy. Policy means some kind of a business process, some kind of a procedure, that is called policy. So this policy is captured in this document in plain English. It's just an English document which says this is the way I work, or this is the data of the application. And then there are a whole bunch of tools. So these are tools. There are n number of tools. Let's say this is tool 1, tool 2, and so on. And at the center, there is an executor. So you give a job to the executor. You give a instruction to the executor. So this is what you want to achieve. The instruction is taken by the executor. Now the executor doesn't know what to do because it's just an instruction. Now the executor uses, before that, this document has been sucked into a, using RAG technology, into a vector database like the Facebook index store. We alluded to it long time back. So the executor doesn't understand this instruction obviously, but it tries to make sense of that instruction and then goes to this vector database to get more sense of the instruction. And it could be more than one document also. And then based on its own intelligence and with the vector database and with an LLM, so basically the executor uses the vector database which has the policy embedded in it, an LLM to make sense out of that, and then it engages the appropriate tools for performing that action. Then this tool are what? Basically Python functions. At the fundamental, they are Python functions. Now, the description of these tools, the executor has already got. So that's the job of the person who sets up the executor, that he has to capture the description of these tools. Tools are functions. So these are Python functions. So it understands what these tools are. It knows what is a policy. it uses the LLM to make sense of the instruction in conjunction with the policy, decides on its own which tools to invoke, invokes those tools, gets the results back, orchestrates among these tools. It decides, okay, first which tool should I use? This one. After that, which tool should I use? This one. After that, which tool should I use? This one. So it is orchestrating among these tools to perform this instruction with a given policy and using the LLM to make sense. And if you ask him to work in a verbose manner, he will also tell you how it is thinking and how it is going about conducting this instruction or executing this instruction, what is it thinking and why is it engaging a particular tool, why is it engaging a particular parameter of that tool, and after that it provides a sequence of the tool and then eventually, of course, generates an output and gives it back to the user saying, this is what I am getting. So this is basically the flow which an executor implements using tools, LLMs, the vector database generally using FIS or something else, and basically gets a job done. So this ability to get a job done which goes beyond just a language question answer is engaging tools, understanding policy and getting things done. Now, why is it of such an important thing? Because if you will figure out, this is one of the reasons why most of the companies are very alarmed by this whole process, because many organizations have spent years developing ERPs, developing, like if you take the example of ServiceNow or take the example of Salesforce. What is Salesforce? At the core, it's a workflow management software. What is ServiceNow? You file a ticket, original, and then based on that ticket, some reactions are taken. Something happens, some flow happens. So if you look at any of those software, basically they are all in threat because all of them now are saying, no, we'll retransform our process to work on an agentic workflow. If you go and research where Salesforce is going, where ServiceNow is going, where any of the top companies are going, which are traditionally ERP companies, traditionally who used to create a lot of cloud software, all of them are saying, now what do I need to do? I just need to create the business process in English, which is what that policy document is, and then I need to provide a few database functions or other functions, and that's it. I don't have to write any procedure. The procedure is going to be figured out based on the circumstances. The intelligence is coming in. See, earlier, if you had to file a ticket, there had to be a well laid down procedure how to do this. Step 1, step 2, step 3. And a lot of Indian employment was spent in basically doing the step 1, step 2, step 3. Now, why do you need that? Why do you need anybody to write that program? It's dynamic. I think you should understand this. See, earlier, if I had to write or implement a procedure, I had to write program in order to write step 1, step 2, step 3. What would that program do? It would implement a policy. How would it implement a policy? By somebody called a domain expert, understanding the policy and writing these steps. So there used to be somebody called system analyst who used to be a domain expert who would understand the domain and said, if this is the problem you want to solve, these are the steps you need to take, and then somebody would engage programmers like us or companies which did programming to say, okay, in order to implement this, this is the program which has to be written, which has to be done stepwise. Now, and that steps would be what? Do this, do that, do that. Now, today what is happening? You don't need to write that procedure. You just have to write the procedure. Whoever the corporate guy is, he has to write the procedure in his business policy, and that's it, he's done. So for example, let's say I have a recruitment procedure and or this is an exercise you will do. Okay, here is a procedure. I am giving you a very simple procedure. See, a company makes products. Company has products. Products have raw materials. Raw material is supplied by suppliers. So I want to make a product. What should happen? I say, I want 500 pieces of a particular product. So what should happen? Somebody should look at that product. Somebody should look at the bill of materials of that product. Once you look at the bill of materials of that product, what will you find? What are the raw materials used for this product? Once you find what are the raw materials for this product, then you have to find who are the suppliers of this product. Then you have to find, okay, I have discovered the suppliers of this product. Now, I have to rate these suppliers based on price and some rating. Is there some rating available? Then choose the best supplier. After I have chosen the best supplier, what do I have to do? I have to give him an order. Now, this is a very trivial procedure. But in earlier days, an ERP was used to implement just this. This was an important part of inventory management. People were recruited to do this procedure. And there were experts who used to get jobs. I am doing inventory management software. Now, why the hell do you need any of that? Because it's all logic. As long as there is a policy which says, I want the best supplier to be chosen based on price and rating, that's all you have to say. And say what are, for this product, what are the raw materials. Done. You just give the data and the data will drive the logic, given a policy. No coding. Nobody is there required to code. See, there is data, there is policy, and then there is agent. So the agent interprets the policy, uses the data, and does the rest of the transaction. Why are you there? This was done by us. And this was a major source of employment. Now, I think please don't think this is only for inventory management. It is pretty much everything that programmers used to do is this. Understand policy, implement a business policy by writing code and breaking it down into smaller steps. Now this is gone. I don't know what else is gone, but this for sure is gone, because if you see, whatever you want to be done, net effect, you just have to say it. And earlier we used to have glorified forms and all that. I had to fill up the data, purchase order data or requisition data, I had to fill it in a form. Nothing. I just have to say, this is what I want, and done. It happens. Well, that is what it will probably do. This is the biggest threat. See, LLMs are not a threat. LLMs are a support. This is a threat. This is a real threat. Okay. And you will see. Okay, now I'm not going to waste too much time. I'm going to walk to the code directly, assuming, because I want you to do at least one exercise, because this, you have to experience this, otherwise you won't get the feel for it. We'll run one exercise and then you will, but before that I'll just go through the code, and after that we'll straight away run the exercise and you will see how it is, and then you will write one. Okay. So I'm just giving an example now, but before I start the example, I'll give the scenario. Okay, this company has a return policy. Okay, it is a text file, nothing more, and a very unstructured text file, if you will. Okay, I'll just walk through. So there is a text file, very simple text file. It has return policy.txt, some policy. Okay, there it says in English, return policy is the first section. Our return policy allows, I'm reading it out because it has impact. Returns within, allows returns within 30 days of purchase. For tablet, the return policy allows return within 10 days of purchase. So if you purchase anything else, 30 days you can return. 10 days is only for tablet. Okay. Then coming down, there is order tracking policy. You can track your order status using your order ID. If you want to know what's happening to your order, it is order ID which you have to use. Again, very simple. And then product information. There is something in our thing called product information, which includes information about specifications and features of the product. Okay, next. Now, and also I have a bunch of JSON. See, in this example, we have JSON. In reality, this data will be all in MongoDB or SQL or whatever. Because I didn't want to complicate the first example, I just took the data and put it in a JSON file. Okay? This is just a simplification. It doesn't matter if the data is in Mongo. It can go to the Mongo if you give the connect string to retrieve data from Mongo. I mean, agents go to Mongo all the time. So here we are giving the JSON right away there. There is some JSON file of various orders. There is order number 1, 2, 3. It has the customer name, order date, products, whatever. Order 1 to 4, order 1 to 5 and data. Then there is some product information. So about 4 or 5 products are there, the laptop, the phone, the tablet, monitor, keyboard, and some description about each product. That is all there. Then going down, then there is something about order status of the orders. So 1 to 3 has been already delivered, 1 to 4 is being processed, and all the other status. You get what? That's it. So this is the data in the file. Some data which you can get from anywhere. Are you with me? There is nothing special about this data. It's just some random data I have collected to build this example. We did that in the morning just to create some example. Okay, some data. Now, how the how the agent will make sense of this data, you will see. Okay, now I have this policy or some data in one place. You can think of policy and data in a more interchangeable way, because that's how it looks at it. So I have some context. The word to use is context. Context can be policy or data or a combination of both. Like here, I have data also in the file and I have some policy, like return for tablet has to be done in 10 days. Anything else, return has to be done in 30 days, something like that. That's policy. So besides that, there is data. So for our platform, data and policy or document is same. Same in the sense, the agent looks at it similarly. Okay? Because for it, it's something which it can consume and process. Okay, so that is there. This is the first file. Then I am going to the program. Let's get into the program and then let's try and understand. See, initially some of it may be hazy, but it will soon make sense. Okay, what am I using? I am using LangChain tools. I am using JSON. Now, as of now, these agentic workflows are working only with, or rather, I should not say that. We have tested it with only 2 LLMs, OpenAI, of course, and the other one is Anthropic. Okay, so we have tested with only 2. Now, I have not tested it with Llama 80B. We tested it with the Llama 7B. It is not working correctly. But Llama 80B we have not tested, may work. So it is something you can, if you want to do, you can do. But for Anthropic's Claude, Anthropic also has many LLMs. It works without problem with Claude, whatever is the latest version of Claude or one version before. So Claude is fine. You use Claude, no? So Claude is fine, OpenAI is fine. OpenAI 4.0 onwards. 4.0 onwards. Now I am not sure whether it is 4 or 4.0 onwards, but one of them. So, yeah. So I need to talk to the OS for interacting with the files. I need to talk to date and time. Now, just look at it. I have created 3 or 4 tools. This is called a tool. Tool means what? A Python function which is invoked by the system. You will soon see the intelligence, but it's a tool used by the Python, by the agent executor. Now, broadly, what does this tool do? Given order ID, it gets the order status. So, if not order ID, there is some logic there. Okay. Now, I am sure I don't want to insult your intelligence by showing you how Python works. So you look at it and you figure out. They are very simple tools. What does the first one do? I'll just describe it in one line. If you give an order ID and it just checks whether order ID, in the prompt there should be order ID. It should be given like order ID equal to. That is what it is expecting. And what does it do? It goes to the order JSON and finds out data about the orders. That is what that function does. So it can go to that file, retrieve data about the order and do it. And how is it doing it? Okay. So, just go up. We'll look at one function. It is saying order.status, JSON.load file, that file, and then order status.getString, order ID not, it is looking for order ID, and if it is not found, not processing it. So, and which file is it looking at? Order status.json, okay? So, order status.json is another, I forgot to say this. See, these three JSONs are separate files, not one file. No, yes. I have shown it as one file, there are three different files. Okay. So it is going to the appropriate file, loading it and getting the data. Okay, next. Save order status returned tool, what does it do? Wait a minute. No, I'll just talk about its function. It saves the order status return. So basically it is, if you go to the code, it is storing the status of the order. Come down. Just updating the order status. The name is not correct. Come down. So if you look at the thing, it is just updating the status of the order as returned. So whichever order gets returned, this function gets called to update the status as returned. It is keeping track of what orders got returned. Okay. Well, that's it. Then there is a get product info tool, which basically, what does it do? It gets information related to the product. Now for a product, what are the information? What are the raw material required and in what quantity? That is the information associated with the product. What are the raw materials? What are the quantity in which the raw materials are required? Okay. Then we have a get order info tool. Given an order, gets information about that order. That is, who is the customer, which date the order was created, all of that. Again, the Python code for that, I am not going into it. And then last function, get today, it just gets today's date, okay, and says today is so and so. Okay, now I am just pausing here for a moment. Have you looked at the functions? They are very simple, trivial functions. They can be written in any language. They should just have a Python wrapper. And they can do pretty much anything. Only thing, now comes the important step. So, basically these are called tools. Now, this is what we will have to write still. This is where the programmer's job is to create these tools. Now, whether he creates these tools using LLMs themselves is also interesting. See, these tools themselves can be based on LLM execution. We are not going there. Right now, the tools I have shown you are created in pure Python. There is no LLM flavor in the tool. So the tool is plain vanilla procedure. And no code, no LLM, no AI in any of these tools. You look at the code of the tools. At no point we are using any AI, we are not using any gimmick, any circus in the tool. Tool is straightforward. Now the reason for showing these tools is most legacy tools will be like this. These will be already written in most companies. So these are the tools which are available. Okay, just keep that at the back. Now we are going to create a tool object for every tool. The most important parts of the tool object are two. First, the function associated with the tool, which we already know, but more significantly, a description of that tool, which the LLM will understand and decide when to use that tool. So this description is very important and that is our job to create. We have to describe what this tool is capable of, because we are not going to invoke this tool. The invocation of this tool is going to be done by the LLM. We are just a supplier of tool, and they can be either pre-written, they can be any kind of tool, whatever. So now just see this, you will understand. Can we scroll up? Yeah, so there is a first tool which says get input from user. I think that tool has come later. It's written later, that function is written later, doesn't matter. What is the job of that function? It's a standard Python function which gives a prompt to the user and gets information, nothing much. It's just a prompter to the user to get information. This will be used by the agent when it feels I don't have enough information to call the tool. Now here I would like you to understand, contemplate a bit. See, sometimes I read a policy and I want to do something, I identify the tool. Okay? When I identify the tool, I realize that the tool means function, needs 4 parameters. Yes? But at the moment, the agent has only 3 parameters. So what's it going to do? It's going to ask the user for the 4th parameter. So it has figured out I have 3 parameters. The function seems to need 4 parameters. There is an extra parameter which I don't know how to get. So I need to ask the user. So at that point, automatically it will ask the user, tell me what this is and give me that, because I don't know. And the function needs 4. I know that the function has to be called, but I don't seem to have adequate data. You give me that adequate data. So it's a very conversational kind of business flow. So it makes you a partner and runs the flow. So this is the first tool. Then for each of the tool, please note the description is to be very carefully given. Creating a tool may be already done, it's just pure Python. But writing the description of the tool is very important, because that is what the agent is going to understand about that tool. So get the order status of an order given an order ID. That is the job of get order status. So it will go to the JSON, give an order ID, get the status. It can go to a MongoDB also. Then the product info too, it gets product info, see the description, get information about a product given its name. Come down. The third tool, fourth tool, get information about an order given its ID. Another tool, change the status of the order for a given order ID. Done. Get today's date tool, get today's date in date format. Okay. Now the tools are ready. So in order to get the tools ready, what do you need? You need 2 parts. One, you need to have the functions of the tools. You have to write that code. And second, you need to create nice descriptions about those tools as to what they do. See, this will come with experience as to create that nice description. Okay. So let's say we have done that. Now starts the main flow where we are using various things. So now this is a code. Now this is a code which will not change most of the time. Whether this agent is there or some other agent is there, you don't have to change this code. This is just the kernel code which will remain by and large untouched, by and large same, whichever agent you want to work. I won't be surprised if you take this agent and make it work with drug discovery, it will work. If you take this agent and make it work with supply chain logistics, it will work. You make it work for a legal framework, it will work. The agent code, which I am showing now. It won't change much. Okay. The agent, obviously, in order to understand the English, needs an LLM. And because it needs an LLM, it needs access to an LLM. Now the LLM should be co-hosted or an API access. So here we are using OpenAI as our LLM. As I said, only 2 LLMs we have tested, this one and Anthropic. So currently we are using OpenAI and we are using the LLM as GPT 4.0 and temperature is obviously 0. Now this is important to maintain temperature 0. What does it mean? There is no uncertainty. I don't want it to get, see, if you make higher temperature, what it will do? It will try to be very creative. In business policy, we don't want it to be very creative. So we are making temperature 0. So temperature is 0. Next. Now we are going to absorb, no, come down. Okay. Now I am going to use several guys. I am going to use the vector database or vector store first. I am going to use a splitter. I am going to use a loader. I am going to use an LLM. I am going to use for my document, I am going to use a PDF loader. And for embedding to store into the vector store, I am going to use OpenAI embeddings. So let's walk through the initial parts. They are very easy. So loader, text loader, return policy. This is just the return policy file, which is only 3 lines. What are the 3 lines there? Every goods can be returned within 30 days. Tablet has to be returned in 10 days. This is the only policy. Yes? All others are data. So this is the policy, that's all. So I load that document. Now, here we are using a very simple policy, but in real life, policies can be 20 pages. You can have any policy. And these policies will be read, captured and put into the vector store into embedded form. So what happens now? Documents are loaded. Now, first thing we'll have to do is, we'll have to split the documents, so in chunks. So that's the thing. We are creating a splitter which will split the document into chunks. You know this. This is a typical vector database. So text splitter will split the documents, and I'll have the split documents. Then I'll create an embeddings object below it. And after I have created the embedding object, I'll use the embedding object and the split documents and build the vector store. So the vector store, vector database is ready. Again, I am not going through each line in detail because some of this we already talked about. Are you clear so far? We have created a vector database in which we have read the return policy or bigger policy if there is. In our case, return policy is very small. We have read it and we have converted it into chunks and stored it in a vector database. Now, we have to create what is called as a retriever. Retriever is basically a reader on the vector database or an indexer on the vector database, or if you want to think it a little more, it is actually a search algorithm which you want on a vector database, some kind of a search algorithm. So you want to use cosine similarity, or you want to use any other kind of similarity search. You can engage any similarity search which the vector store supports. So, we are creating a retriever using vector store.asRetriever. Can you scroll to the right? And we are basing it on similarity scores. So the search will be based on similarity search. Normally it is cosine similarity or one of those kinds. There are different vector databases support different similarity searches. So you can use one of them. So again, we are not going there. It's a threshold based. Anybody crosses that threshold is a hit. Okay, go to the left. Yeah. Now I am coming to the retriever tool. Now I am creating another tool called the search tool. So tool search is create retriever tool. The retriever which I have created, I have done it earlier. Then see the good part of the description, searches and returns policies, product, etc. So this is going to be the basic search tool used for policy. That is what I have indicated. This is the tool to be used for searching. Okay. Okay. Then we are creating the tools by saying tools object, by saying load tools. We are specifying the LLM which has to process the tools and creating an empty list. Now each tool is getting added to it, whatever tools we have created so far. So tool, search tool, input tool, order status tool, product info tool, all these tools are getting added. So if you really see now, what have we got? Okay. In summary, we have got two things. We have got a whole bunch of tools ready. Second, we have got the policy sucked into a document, and we have tools to search the document policy plus tools to do action. Even searching is a kind of action only. So we have tools to consume policy, tools to perform action. We have got all these ready. And now starts the interesting part. Okay. Now, Now we have to create a prompt. Now, normally you can create a prompt which is as simple as this. You can say, you can tell the agent executor something like this. Use the tools and the tool chain to understand what the user is asking and perform actions based on what the user is asking and give a final response. This can be a simple prompt. This is a simple instruction to the executor saying, use the policy, use the data, perform actions and get a response. This is all that is. But there is a much better way of creating this prompt. So what most agent executors do is, rather than using a general purpose prompt, they use a specially created prompt called the React prompt. That is reasoning and action prompt. This is a pre-created prompt. You can go to Google and Google this. You will see the prompt. Let's do that. Just take that and search for it. You will see what that prompt is. It's a typical English prompt, but pre-created. Yeah, open it. So this prompt says this thing. Answer the following questions as best as you can. You have access to the following tools, which is tools. All the tools which you have created will be at the disposal of the thinker, of the agent executor. That is what that tools means. And this is the following format in which we want the agent executor to think. The input question means the input question you must answer. Thought is, you should always think about what to do. This is what I am telling the agent executor. This is what you should do. And action, the action to take, that is the tool to invoke. Then action input, the input to the action. You have to observe the result of the action. And then you have to proceed this n number of times. And you have to finally give the answer to the original input question. This is an instruction which we are passing via this prompt to whom? To the agent executor. So we are telling the agent executor that you need to do this. We have given you the document, we have given you the tools, the policy and the tools, and we have also given you an LLM. Now you will take the user's instruction and conduct yourself as per the user instruction. Okay. So that's just the prompt. So this is a pre-created prompt. So instead of creating it every time, most people use a standard prompt which has been pre-created and put it in. So this is the prompt. Then, okay, there are some LangChain agents where we import the create agent executor and the reasoning agent. Okay, now starts the important work. So React agent, we create the React agent using three things. Now this is where they have put all things together. What are the three things we require for the agent executor or React agent? We need an LLM, which in our case is a ChatGPT 4.0. We need tools, which are those functions which will do work. And we need a prompt, which is the instruction that I need to obey. So always three things for an executor. One, which LLM you want to use. Second, which tools do you want to use. And three, What prompt should I follow? Just that. Okay. Now, we have the main execution. Define prompt user for info. Prompt user for info. So now, look at the way I am doing it. This is only one line which will execute. This is the only code. I'll ask the agent executor. I'll invoke the agent executor, or I'll call the invoke method on the agent executor using the query. The query is what is going to come from the user. This is the first time user starts interacting. He gives a query. Query means something the user wants to know or wants to do. So query. And then if please provide is there in the output, then you have to again refine your output and give it back. So input, response, output, prompt the user for additional info. Sometimes, I told you, sometimes the agent executor will feel that a tool needs more information and I have not given so much information. So it is asking the user, going to ask user for more information. So look at the way it has captured. If the response contains please provide, that means the response is not able to proceed. It wants more information. So in that case, I will again ask the user for more information. So new input, response, output. I'll give this to the user and take a new input, and then prompt user for new input. I'll go on and give the, I'll call that recursively and get a response. I'll go on doing it till I get a response. Okay, come down. Okay, done. Now, this is all that is code. Okay. Now, in this file, we have included three instructions and how the system responds to those instructions. Now, what is also there is, okay, there is one more thing which I should show you. Go up. Verbose true ka hai? See, I didn't talk about this line. So the React agent is created. Now the React agent, I have converted that into an agent executor. With that React agent tools, one setting is there, which is very important, which is called verbose equal to true. What does that do? It exposes the thinking of the agent as it is thinking, like a human brain. What is going on in the brain, it will tell you, this is what I am thinking, this is what I am doing. That's why I am doing. This is called reasoning. Now I want to stress this. Okay, try and understand what I am saying. One of the major allegations made against GenAI is, it is not explaining why it is doing this. See, even today, nobody knows why does a CNN work. Because it doesn't follow any logic. It just goes training, waits, updating, gets updated. Same thing with LLMs also. See, this ability, nowadays they use a word called explainable AI, XAI. What is XAI? AI which can explain its answers. This was not happening. LLMs never did it. CNNs never did it. RNNs never did it. They never told you why I think it is a cat. They never told you why I think the next word should be this. They did it because of training, and we surmised that somewhere they are understanding. But they never told till date, and LLM never told us how it is understanding or why it is understanding. It was always conjecture that, it may be thinking like this, or it may be doing like this because it is thinking like this. There was never in the history of LLMs or AI, especially the Gen AI, any attempt towards explainability. Why? Reasoning. Now you will see a substantial difference, and that is why I am stressing on that verbose equal to true. The agent will tell you why I am thinking like this and why I am taking this action. It will expose its inner thought process, and that is where alarming starts. because it says, why am I doing it? The reasoning, see, so far, reasoning was absent in AI. On machines, in computation, 2000 years, there was no reasoning. Whatever reasoning was there, I wrote the code. It did not reason on its own. Now, you will see, now, just now in 2 minutes, it is reasoning. And follow me as I go. Okay, come down. Okay, now, we are going to follow this through. I gave a query to the agent saying, get product information of the order. Now, look at the way the blind question is there. Get product information about an order. Now, I never said which order. Did I? I never said which order. I just said get information about the order. Get product information about an order. That's all I said. I never told it anything more. Okay, now, the one which you are seeing in green, I hope you are getting the color. No, yes? You are seeing something in green. Green is the thought which the agent is thinking. It is not written by me or written by you or written by anyone. It is its own analysis of what is happening and how it's reacting. Look at the green portion. To get the product information of an order, I first need to know the order ID. Is it not starting to act like human? It is saying, if I want to give you information about an order, I ought to have order ID first. So, now what does it do? So, I have to ask the user for order. Is there a tool available for that? There is a tool I created called get input from user. Are you with me? So, I need order ID. You have not given me, but you have given me a tool which gives me information, which allows me to ask you for information. So, he says action, get input from user, and action input, what he is asking it to do. See, this action input is also created by it. Please provide the order ID to retrieve the product information. Now, this line has been created by the tool because it wants order ID information. So, the thing which appears in red, okay, the thing which appears in red is the one which has been typed by the, which is coming out from the system. Are you with me? Are you able to make out green and black? Okay. Green is my thinking. Black is my output. Yes? So, what appears on the system is, please provide the order ID to retrieve product information. So, the user types 125. Okay. Now, he says 125, I have taken 125. Now he says, okay, I got the order ID. What should I do now? Okay, now I have the order ID. Now I need to retrieve the order information using this ID to get product details. You are with me? So I want to get product details using this order ID. So I am going to do that now. Now it says, do I have a tool for that? Well, there's a tool there called get product info, whose description says that if you give me order ID, I'll give you product information. So now what is this doing? Wait, please provide. Sorry, that is come again. Okay, now it does get order info. Now there is a format thing there. See, it needs order. Now this has come in ulta order. See, it needs order ID in the format order ID equal to 125. So it's asking you again that I want it in that format, order ID equal to 125. Don't say 125. Say order ID equal to 125, then I'll proceed. So that is that English. Now it has got the order ID. Now the thing what it's doing is, it's going to order info, giving the order ID, and getting the customer name, whatever, data about the customer. And then it is now formatting using this, the reply. So I have retrieved the order information. The products in the order are a tablet and a laptop. So it produces an answer now. The products are a laptop and a whatever, tablet. So this is the answer. Now very simple. Did you understand what it did? No, yes. The green portion is the thought. And now that final answer, what it has thought, will appear. Okay, come down. So finish the chain. Input was get the product information on the order. It asked you for the order ID and all. And final answer was the products in the order are a tablet and a laptop. So all the green thing has happened. It has asked you for order ID also. And it has responded. This is the data I want. Got it? Now, normally, this would require human being to write a procedure. No, yes. You would write steps in a program, Java program or C program, whatever, where you would take the order ID, ask the user for order ID and all of that. You just asked an English query and it responded with all the information it needed. You had to supply the tools because the databases and all are still there. Okay, let's go down. Okay. How many days before I ordered? How many days before I ordered? It is, that means how many days have passed since the order. I have not given the order ID. I am asking how old is the order in Hyderabad English. Okay. What was the question? How many days before I ordered? I am not, which order? Nothing. I am just asking how many days since I ordered. Now, just this question. So, now see the English, see the thinking. To determine how many days have passed since your order, since you placed your order, I need to know the order date. So, it thinks I need to know the order date. So, in order to know the order date, I can find this information if you provide me with your order ID. I have to first get the order ID, then I will get the order date, and then I will tell you how late is this order or how old is this order, right? So get input from the user. Now it's going to ask the user, please provide, now that black thing, please provide order ID so I can check order date. See, the prompt to the user also is customized, if you see. It's being built on dynamically. So he again enters 125. I think again it goofs up. Yeah. Again it goes through that, please provide in that format, order ID is equal to 125. Let's say you give that. Now it gets the order info, like earlier, gets all the data about the customer. Now it says, I have the order date, which is November 30, 2024. Now I need to find out today's date to calculate the number of days since the order was placed. So it then calls a function to get today's date because that function is there. So it says, okay, let me figure out today's date. So I say, get today's date. Now it says, okay, now today's date is so and so. Now I have both the order's date and today's date. The order was placed on such and such day. Today is so and so day. To calculate the number of days placed since the order was placed, I subtract the order date from today's date and he gives the answer, you ordered 5 days ago. Come down. So, the question is, how many days before I change order? It asked you for the order ID and reported you ordered 5 days before. Done? Again thinking, again analyzing. Okay. Now let's go to one more deeper level analysis. Now, are you at least getting the understanding? These have started thinking. All the green thing, that is where it should appear red to you. No, yes. Because this will get increasingly more complex. As the LLMs become more and more smarter, the green will become more and more smarter. And there is a second point which I hope you are not losing. It is reasoning like us. So it has not only assimilated knowledge, it has assimilated thought. You agree? No? It's the beginning of thought. You should grasp that. We can make it, we are not making it think, it is thinking. Okay, let's see one more. There are many more. Return my product which I was ordered. Again, our English. Okay. Return my product. I want the product which I ordered to be returned. That is a simple question. Again, I have not given order ID. I have not given anything. Okay. So, to assist you with returning your product, I need to gather some information about your order. Let's start by getting the order ID. Okay. So, we got the order ID. I will skip this part. Okay. Now, order ID is there. Now, it figured out what is the status of this order. Okay. It on its own figured out that in order to know whether I can return it or not, I have to first see whether this order is already not returned. You can't return an order which you have already returned. It is going and checking. See, it automatically decided. It seems I need to format the order date to proceed. Let me do that. Get order status. So the order with ID 123 has been delivered, so it can proceed with the return process. Now, it is saying I need to check the return policy to ensure the product is eligible for return. So, basically the thing which it is doing is that we want to check whether this product is eligible for return at all or not. Remember, we have two policies, 30 days for any product and 10 days for a tablet. Those are our policy. So, now it is saying search return policy. It is automatically going there. So, it is getting the return policy. It has retrieved that return policy. And it has also found out this is the return policy. Come down. Now, let's look at the green portion again. The return policy allows return within 30 days of purchase for most products, but for tablets, the return period is only 10 days. To proceed, you need to check if your product is eligible for return based on this condition. Let's find out more about your order. So now it's exploring your order. So it went to order info, got details about order. So far it has only checked for the status of your order. Now it's getting the data of your order. Then it is saying the order includes a laptop and a monitor, and it was placed on 22/11, 1st January. Since the return policy allows only 30 days of purchase and the order date is well beyond this period, the products are not eligible for return because they have been ordered late, okay, pretty late. Okay, then final answer, see the English. Unfortunately, the products in your laptop, in your order, laptop and monitor are not eligible for return as the purchase date is beyond 30-day return window. All this it has figured out on its own. All the green portion. It has figured out that 30 days are elapsed, and another smart thing it has done, if you realize, I don't know how many of you caught it, it went automatically and checked against the bigger policy, older, that is 30 days. It didn't even bother to check for 10 days after that. Though there is a laptop and a tablet. No, there is no tablet, is it? Oh, sorry. In this case, there was no tablet, so the only 30 days was checked. Yes, no? I'm sorry. Only 30 days were checked, and it automatically checked what is today's date. It checked when the order was placed and said not eligible. Now, this ordinarily a human being will do. No, yes? And if you combine this with voice, do you understand why now you don't need call centers? Just this one example will tell you Whatever a call center can do, however smart it can get, this guy gets smarter. And he can work all shifts. It doesn't need shift transition, shift overlap, nothing. It can go on working. And just this simple thing can replace most of the call centers. Most of everything, actually. Okay. Now, one more, I think, one last. Okay. Now, in this case, yeah, just go up. Go up. This is the last one. Just one more. Yeah. Again, please return my product which was ordered. This time I will give a different order ID. So if you see this order ID, it was 125. Come down. Now, come down. The return process for order ID has been successfully initiated because it checked its. If you have any further questions or further, invalid. So it found that it is eligible because order 125 was within 30 days or whatever days. It discovered that and said process is initiated. Okay. That's it. So there you are. Now you could build this to any level you can. And this is all working code. It's not, we ran it n number of times every day. We are using this extensively in what we are doing. And I hope you guys will start using it. Because if you don't use this, you know, where will you find the biggest employment in LLMs, in Gen AI? I said 3 things. That time I mentioned 2. One is, every company is going to need an LLM. That will come either through RAG or through fine tuning. Those are 2 jobs. Those are going to be huge. The third job is this. This is going to be bigger than those 2. You know, when will this end? What is after this? Let's think. This is right now the cutting edge of Gen AI. It has reached here, which is what? Agentic workflows. This is an example. Examples can be more complicated. Searching databases, searching web, searching. In fact, even ChatGPT is doing this all the time. It is using agentic workflow. See, if you give us information about what happened yesterday in the Maharashtra assembly, it's not saying I don't know. What is it? It's figuring out it's not there with it, and it's invoking a search tool. Correct? Going and retrieving information. Today, almost all ChatGPT is agentic workflow. That's why it's becoming smarter. It's able to do more things than what it was doing earlier. And these tools are not going to stop. They are going to get smarter and smarter because all they need is GPUs. Exactly. I already alluded to it, no? Right now, tools I am writing. No, yes? How long does it take? Now, tools can be automatically written, no? And compiled or run. How long is it going to take? Generating Python is no big deal. Generating anything is no big deal. So it can do pretty much everything. This, if you are not alarmed, you are not understood. Especially the green things. The green things are potential bomb. What kind of bomb, I don't know. But they are dangerous. Extremely dangerous. And they are also telling you how they are thinking. They are not obligated to tell you how they are thinking. Okay. So, now we have exercise for you where most of the LLM code is given. Now, most of the agent executor is given. You have to write those 2 nice functions. That's it. Just to give you a hang of how it all works. And it's a very interesting example, what I alluded to, bill of materials and product and identifying supplier and all that. So, Just write the two functions, run the code. You will yourself understand the power. So we'll open the exercise. It's a Jupyter notebook, of course, on Tantric. Develop it and then run it. You'll have to develop two small functions. Okay, it started. You should get 2 notebooks to do. Well, not 2 notebooks, 1 notebook. You have this code already with you. Use this code and write that. Let's see how many of you can.